All right, last chapter, well, last section, sorry, of the chapter. It's not the last chapter. There are 2 more sections in here, but I'm going to not do those. It's not that they're not important, but I want to get to the next thing. I think it's a good place to stop. All right, here we go. We're doing circles again. Whole chapter's on circles, right? So we might as well do more circles. We didn't. Well.
What is this?
All right, so we got a circle. We've talked about, I'll tell you what, let's put a center right there. I don't think I need a center actually on this one, but I'll put it there anyway. And let's group that and let's copy that. Okay. Let's review just briefly. So what did we call that angle right there? This angle right here, we gave it a special name. The vertex is at the center. Right, the vertex is at the center, so we call it the what? Central angle. What do we know about the central angle and the arc that it cuts off from here to here? They're equal, right? So if this is 120 degrees, what's this arc right here? It's 120 degrees, okay? What if I drew an angle from a point on the triangle, on the circle? Everybody see this? That point right there is on the circle. What about the center of the circle? Is that on the circle? No. Where is it? It's in the circle, right? So this is actually on the circle. I was watching a math video yesterday, like I do sometimes. I know, I'm such a nerd. My wife was sleeping upstairs. She came down and she just shook her head and just laughed. I can't believe you just sit down here and watch math videos. But I think they're kind of interesting. And I was reading some comments on the video. And they were talking about a circle, and they were talking about finding the area of a circle. And then some people get so bent out of shape. Some people just don't have anything else to complain about, I guess. They get bent out of shape, and they said, well, it's not really the area of a circle. They said the teachers get really mad when they say area of a circle, because the circle is actually just the line that goes around it, okay? So it doesn't really have an area. And plus, the line that goes around it doesn't have any thickness or width, right? And so they're saying, well, the area of every circle is 0 degrees. So somebody said it's the area of the plane that the circle's on or something. I don't know exactly what they said. But they get so picky, you know? But we all know what we're talking about, right? When we talk about the area of the circle, we're talking about this. But when I say the point is on the circle, this is not on the circle, okay? That's in the circle, and this is outside the circle. This is what? On the circle. Okay, so we call this an inscribed angle. Inscribed. And what do we learn about the inscribed angle? The angle is how much of the arc that it cuts off. The angle is half of that arc. So if that arc, see how it cuts off that arc right there, 120? Just had a quiz on this yesterday, right? If this is 120, what's this angle right here? It would be half of it. That would be 60 degrees. You got it? Okay, we're going to do a couple things very similar to that. Let's put that circle back. All right, and we're going to look at the arcs and look at the angles, and we're going to figure out, okay, what's the relationship between this angle and this arc? But we're going to do it with more than just...
You need to go back to class. Chance, Mackenzie, go back to class.
So we're going to do this with other things than just chords in a circle, okay, or the radius in the circle, all right? So we are going to hit a couple other things. So first one is I am going to put a chord right there. Now, if I extended this, we've used this word before. We haven't used it in a while. But if I extended that, do you remember what that name is? No, it's not tangent. Tangent hits at what? This is a secant, okay? This is a secant. All right? Now, technically, it is a line, right, that keeps on going like this. But what I'm going to do is I am just going to stop and start it right on the circle. You okay with that? So it's a chord, that's true, but you could also think of it as a secant. Does that make sense? All right. And then you said this word before, but it's not really. Let's see. Oops, I don't think I drew that very well. I'm trying to make it so it only hits at that one point right there. All right. So it hits at this point. See where they intersect each other? I'll make a big old point, okay? So that big point right there. What do we call that thing? That's a tangent. Why is this a tangent? Only hits at one point. Point of tangency. Very good. That right there is the point of tangency. Tangency. All right, there we go. All right, so we got a secant and we have a tangent. Now, an angle is formed. A couple angles are formed, okay, but I'm going to look at one particular angle. There is an angle that's formed between that secant and that tangent. You see that right there? See, it even goes a little outside the circle, doesn't it? Right? There's that little gap right there. All right, so there's a little bit that goes outside the circle, but that angle between the secant and the tangency is what we're talking about. It doesn't really have a special name or anything. It's just the angle between the secant and the tangent. All right, that's all that is. Okay, but they have to intersect at the point of tangency. All right, so all this situation has to be true. You see that? That secant hits the point of tangency. All right, so that angle that's formed right there is got a relationship between the arc that is formed. Here's the secant, it hits right there. The secant hits right there. Tangent is there. What arc are we talking about? We're talking about this arc right here. Okay? Everybody see that? There's a relationship between this angle, this little skinny angle right here, and this arc right here. And it's exactly 1/2. It's kind of like the inscribed angle, isn't it? Because the inscribed angle, where does it intersect? Right on the circle, doesn't it? So does this, but it's not between two secants, and it's not between two chords. All right, it's between a tangent and a secant. All right, so this angle right here is actually half of this arc. So let's give it some letters. We'll call this AB. Yeah, that's. We'll put another point on here so we can name that. So this angle right here is what? Angle A what? ABC, right? ABC. So that's the angle. So the angle is half of the arc that it cuts off. What is this arc? Arc what? AB. Good. Everybody see that? So that's our first theorem on this section.
Ninth graders back to the lunchroom.
Nope, you stay.
Ninth graders back to the lunchroom.
Stay here. I'm teaching you. All right. So you guys didn't make a mess, right? Okay, good. So I'll just say that they told me they didn't make the mess. So ABC. This angle right here is half this arc. So if I told you what the arc was, I don't know. It wouldn't be that. It would be, I don't know, 160. Let's say it's 160. Okay, that arc. What is angle ABC? 80 degrees. That's it. Okay, so this angle right there is 80 degrees because the angle is half of the arc. What if I went the other way? What if I told you that that angle was 80 degrees? Then what's that arc going to be? Be 160. You get it. Okay? You can go either way. So the arc, again, is twice as big as the angle. Very, very similar to what we just finished doing with the inscribed angle. Would you agree? All right. Now, same thing here. If I wanted to figure out, let's call this D, right? If I wanted to find that that angle, and I knew that arc right there, okay, it would be the same deal. It wouldn't be the same degrees. What would it be, actually? If this is 160, what would it be from, we'll put an X right there. What would arc AXB be equal to? 200. Very good. So this would be 200 degrees. So what would this angle right here be? 100. Does that make sense with our math? Yeah, because if this is 100 and that's 80, yep, that forms that straight line right there, doesn't it? See how it all works out? Yeah. All right, enough of that. Everybody good with that? Yep. They have an example. I think what I just did right there was good enough for an example. All right, so I'm just going to go on to the next thing. Now this one, we have, instead of one secant and one tangent, this time we're going to have two secants that intersect each other inside the circle. Okay? Now that's the key to this. They intersect, what did I just say? Inside the circle. All right? I'll make them go all the way through on this one. You could, I guess, stop them right on the circle itself, but in my notes, it looks like this. And we'll put some letters in here. We'll say that point is A, this one is B, C, and D. And we'll call, where they intersect each other, we'll call it E. And it has a center, but I don't really need the center in this situation. Now, this is a little different. So let's watch what we're doing here. Let's go blue. Look at this angle 1 right there. See that? Now, this is not at the center. Do you see that? Okay, we specifically drew it so it's not at the center, so it wouldn't be a central angle. All right? Because we already know about central angles. This is not a central angle. It's just somewhere inside of that circle, right? No big deal. So if you know, or if you wanted to find angle 1, I'll just tell you. The relationship between angle 1 is this. What we're going to do is we're going to take the arc that angle cuts off. Do you see that? See how that arc goes through the circle at A and at B? So it cuts off that arc AB. Now, tell me something else. If this is angle 1, what's this angle right here going to be? It's going to be the same thing, isn't it? All right. If you want to call it angle 1, you can. I didn't really do it in my notes, but we'll do it right there. Check this out. Now, does that mean these two arcs are equal to each other? Because these angles? No, because that's not a central angle. If they were central angles, then yeah, those arcs would be equal to each other. But here's the relationship. Everybody watching? So angle 1, I'll just do it right here. Angle 1 is equal to the sum of the two arcs divided by 2. So it's kind of like the average. All right? So this angle right here, both of these angles, because they're the same angle, because they're vertical angles, right? If you take the average of those two arcs, that's what that angle is equal to. All right? So what would I say? Angle 1 is equal to arc AB plus arc DC, what? Divided by 2. Okay? Or you could put a 1/2 out in front of it. All right? The book might put a 1/2 out in front of it. It means the same thing. Everybody got that? All right, so if I took those two arcs and added them together and divided them by 2, then I've got that angle. All right? I think I will do an example with this one.
Angle 1 equals that? Or?
Yeah, angle 1.
Okay.
Right there, see? Angle 1 equals this arc plus this arc divided by 2. Let's just put some numbers in. I don't know exactly what they are. So let's say this is 30 degrees, and let's say this is 40 degrees, okay, just to make it easy for you. So how would I find angle 1? Yeah, 30 plus 40, what? Divided by 2. That's 70 divided by 2. What's 70 divided by 2? 35 degrees. So angle 1 would be 35 degrees. So would this angle right here. How could I find this angle? If I know this is 35, how do I find this one right here? I don't have to do 360. I just from 180, right? Because I got a straight line right here, okay? So if that's 35, I just take it away from 180, and that's what, 145? Yep. So that would be 145. So you can see you can find a bunch of stuff then, can't you? All right? Okay, let's do an example. It's from the book. It's basically what we just did, but looks a little different. So it'd be good to do this. All right, there's my two secants. They tell you that this arc right here is 45 degrees. and they tell you that this arc is 85 degrees. Now, if they just put a 45 just like sitting right there, what's it between? Between what? It's where those intersections are, right? You see that? So that's automatic. I think somebody asked me yesterday, like, what does that degree symbol mean? Is it from where to where? All right. Well, it's from this intersection to this intersection. All right. Does it make sense? I wouldn't put a 45 here if it went from all the way to here to here. All right. It's just from there to there. This 85 is from there to there. All right. This is angle 1. They call it angle 1 again. And I believe that's all they give you. No, I think they give you one more thing. But I wrote it in a different color. Why did I do that? Oh, I know why. Because I forgot I give you this as 120. All right, there we go. Now that's everything I give you. All right, and they want you to find angle 1. Everybody good? So, Mickey, you know all this already? So you can read your book? So let's check it out. Here's angle 1. This right over here would be the same thing, right? So really, what did I just learn? I learned that if I take this arc and I take what? This arc right there, and if I add those two up, divide them by 2, then I got angle 1. What's my problem though? Don't know this angle right, or this arc. Don't know this arc right here, do I? But can I figure it out? Can I figure out what this arc is? Yeah. How do I do that? Yeah. Let's do this. 120 plus 85. What's that? 205, right? 205. And then add the 45, which is what? 250. And then what do I do with that? You got it. Take it away from 360. Let's do it like this. 250, like that. Just make it easier to see the math. That's 110. So this arc right here is 110. That was old stuff, right? We didn't have to learn this lesson to know what that arc is. But what's the new stuff? The new stuff is, in order to find angle 1, I got to find the 2 arcs that it cuts off, and I got them. Those 2 green ones. And what do I do with those? Add them up, right? Everybody see that? The 110 and the 85, and then do what to it? Angle 1 equals divided by what? 2. That's what? 195 divided by 2, and that comes out to 97.5. So angle 1 is 97.5 what? Degrees. Are you guys guilty of not writing degrees when it's an angle? Some people haven't, because I remember on that quiz, I did that with a lot of people. All right. Everybody good with that? Yeah, that wasn't so hard, was it? Just had to find this arc right there. That was the only thing. So you had to think a little bit extra, right, instead of just performing that theorem. And then you're good to go. All right, let's do another one. So, these are 2 secants that intersect where? Where do those 2 secants intersect? Nobody playing along? Come on, help me out. Where are those 2 secants intersecting? Inside the circle, right? It's in the circle, all right? This is inside the circle. That's very important because of what I'm going to do next. What do you think I'm leading up to? That's right. We're going to have 2 secants that intersect where? Outside the circle. So inside, what do? You take the 2 arcs and you do what? You add them and then divide it by 2, correct? I hope you're watching, because the next thing is going to be a little different. So when they intersect inside the circle, you add the 2 arcs together and divide it by 2. Okay? All right. It's not the same thing. It's different. That's why I'm trying to get you to understand, when they intersect inside the circle, you add them, divide by 2. So where do you think I'm leading to? I'm trying to get you to think. If they intersect, no, what did I say they were going to do? I said they're going to intersect outside the circle. All right? So, like this. All right, do those 2 secants intersect outside the circle? Yes, they do. I'm going to write that down. Outside. I'll just put outside. You know what I'm talking about, right? So they intersect outside the circle this time. You see that? That's not in the circle. Let's take a look at the arcs that they cut off. Well, where are they? Here's a 2 secants, right? So this angle right there, everybody see that angle? All right. That's formed by those 2 secants. What arcs do they cut off? This little tiny one right there and this bigger one right there. So those are the 2 arcs that they cut off. Let's put some letters in for this. Okay, we'll call this A. This is B, C, D. Oops, why did I do that? This is E. I don't know why I made that E. Maybe the book did. And this one is D. Yep, that's everything. All right, so now check this out. This one's different. It's not much different, but it's different. Okay, they're 2 secants that intersect outside the circle. Now, you're not going to add the 2 arcs and divide them by 2. What do you think you're going to do? You're going to subtract the 2 arcs and divide it by 2. Okay? So you're not finding the average of them this time. You're subtracting them. So we'll call that angle 1 again. So angle 1, what's it going to equal? Now, it definitely matters which one you subtract. Okay, from what? You always take the smaller one away from the bigger one, right? So bigger one first, smaller one second. What's the bigger arc out of the 2? CE, because it's further away, right? Since that's going out like this, the further out you go, the bigger the arc gets. All right, so it would be arc CE, what? Minus arc BD. And there it is. Oops, divided by what? 2. Everybody got that? Did you see the difference? Okay, trying to make a big deal about this because a lot of people forget. All right, when they intersect inside the circle, what do? You add them together and divide them by 2. When it's outside the circle, what do? You subtract the 2 arcs from each other and then do what? Divide it by 2. Okay? Can you keep those straight? All right. Hope so. You ready for another one? The next 2 are the same exact equation. All right? But this was, let's write this down. This was what? 2 secants, wasn't it? So we're going to mix it up a little bit on the next one. So instead of 2 secants, we've actually done it once already. Where did we do it? Right there. Okay, we had a tangent and a secant, didn't we? We're going to do it again. Yes. All right. Let's move on down the line here. There we go. And so let's do a tangent and a secant again. I'm going to make my tangent kind of go like this. And it intersects right there. So that's my point of tangency. Now this is a little different because remember the other one where you had the secant? It hit at the point of tangency. Do you remember that one? That was the first one we did today. Yes? Looking in your notes? Hit at the point of tangency. This one, this secant does not hit at the point of tangency. And it also intersects not on the circle, but outside the circle just like we did. Except, now what do we have? We got 1 tangent and we got 1 secant. And where do they intersect? They intersect where? Outside the circle. Okay? You with me? Now the math is the same as the one we just finished doing. All right, where we had the 2 secants. I'm going to make that angle 1 again. All right? Now, what arcs does this cut off? This angle right here. Let's do kind of go with a thicker brush. So watch the arc that it cuts off. It cuts off this arc. You see that? At that point of tangency to where it intersects the circle right here. Those are 2 places where it intersects a circle. And where else does it intersect the circle? Let's do it let's do it orange. From here all the way to there. So this is a little bit different because they both come to a point here, don't they? All right, so it's a little bit different than the other ones. That's why it's a brand new theorem. All right, so let's do this color. Let's put some letters in here again. We'll make this one A. And then we'll go around the horn here. So that's going to be B. This is E. This is F. I don't know where the C and D went, but that's okay. Yeah, that's good. All right, everybody ready? So what is angle 1? Angle 1. Remember, we said it's the same formula as the last one we just did with the two secants that intersect outside the circle. So when they intersect outside the circle, it's the same formula. But what are my two arcs that are cut off here? BA. And what are we going to do with the BA and the other arc? Same formula, so we subtract. And then what? EA, right? And then what do we do to it, though? Divide it by 2. And there you go. So it's the same exact formula, except this time you got a tangent, you got a secant. They intersect outside the circle. All right? They don't intersect at the point of tangency like our very first one was today. So that's nice, right? You got two of them that have the same exact formula. So that makes it a little bit easier. We got one more that has the same exact formula. You ready for this? Everybody awake? Snap out of it. So we had two secants. Then we had one secant, one tangent. What do you think this one's going to be? Both tangents, right? Two tangents, okay? And they intersect outside the circle. Everybody good with that? All right, so how do we draw that? Well, we've got to make this tangent like this. And let's make this tangent. And they got to intersect outside the circle. There you go. And I'm going to just extend this one a little bit. And we'll extend this one a tad. All right, they're both tangents. All right, here's the point of tangency right here. Here's this point of tangency right there. Do you see the angle that they form? This would be the angle 1. We've been using angle 1. Might as well stick with it, right? Now, what are the two arcs? Let's put some letters in here, huh? Call this A. We'll call this one B. We'll call this C. And we'll call this one up here F. That's a B. It's a weird looking B. All right. Well, might as well stick to what we've been doing, right? We've been showing you these arcs. So it cuts off that arc right there. And what haven't I used? Let's use yellow. And it cuts off that arc right there. Everybody with me? All right, so let's do this in orange. I don't use orange very much. I should start using orange more. Do you like the orange? It's kind of bright, looks nice. All right, so what do you think angle 1's equal to? Without me telling you, I bet you could figure it out. No, what arcs? Now, which one's the bigger one? The one that's further away. It's always the one that's further away from the angle. So which arc is the bigger one? CBA. And it's a major arc. That's why we use 3 letters. Okay? If I just said CA, I'd be talking about the orange one. Okay? If I talk about the yellow one, I got to call it something else. I'm going to call it CBA. All right? So arc CBA. And then what? Plus or minus? Minus. And then what's the inside arc? CA. Do you see the difference between the two? This is major, this is minor. That's the bigger one, that's the smaller one. And then what do we do with those? Divided by 2. So the last 3 things we just did have the same exact little formula for it. Okay? But they look a little different though. All right? So the arc that's formed, the angle that's formed is equal to the difference of the 2 arcs divided by 2. Make sense? Yeah, let's do an example, N we will be finished. Pretty easy so far, right? Yeah, you just got to remember all that stuff. Sure, Mr. Hamrick, it's easy if you remember everything. Yeah, exactly right. If they intersect inside, it's plus. If they intersect outside, it's minus. And if they intersect right on the circle, like that first one, you're not even subtracting or adding, right? Because you only get one arc, and you just take that arc and divide it by 2. But every single one of these you're dividing by 2. All right, so remember that. All right, here we go. Let's draw some stuff. I'm going to have a point out here. Call it point X. And I'm going to draw a couple tangents and a secant from that one point. All right, so here's a tangent right there. All right, here's another tangent right there. And let's draw a secant from that same point, point X. We'll draw it to about right there. That looks nice, doesn't it? Okay, that's X. This right here is W. W is where it hits the point of tangency. Let's see. This one is Z down in here, point of tangency. This is Y. All right, and then they give you some numbers. So they tell you that this is 88. They tell you this is 145. They don't tell you this XY. They make it A just to make it a little easier for you, I guess. And I think that's all they tell you. Oh, they do tell you this point right here is V. Little a is that arc right there. Everybody see that? Okie doke. All right, so you're going to find 3 things. Let's do this. Let's push this up a little bit. We'll do it here. So we're going to find, part A says find angle YXZ. So it's an angle YXZ. And then part B, we're going to find arc WY. And then part C, throw it down here, we're finding arc WV, West Virginia. All right. First 2 shouldn't be that hard. Number 3 takes a little bit of work. So maybe we'll figure it out. All right, let's mark it. Let's find out where angle YXZ is. Where's Y? There's Y. X right there, and then Z. So which angle is that part A? It's that one right there. Do you see it? There's Y, there's X, there's Z. So that's the angle. Remember, it's an angle, not an arc. And that's what you got to find. What do we do? Well, this comes out like this, right? This comes out like this. What arcs? So we got a secant and a tangent, and it intersects outside the circle. So what's the first thing that pops in our head when they intersect outside the circle? Okay, that you subtract and divide by 2, okay? So what are we subtracting? Yeah, it's just the 145 minus the 88. And then you divide it by 2. I already did the math, and it's equal to 28.5. And it's degrees, so we put it degrees because it's an angle, right? So you put degrees. All right, so that angle right there, let's draw it in there, 28.5 degrees. So that was easy, right? What about arc WY? I didn't even, oh, no wonder. Forgot something. I was going to say, how in the world are we going to find that? They tell you that whole arc right there is 40 degrees. 40 degrees. So that's important. I forgot to put that in there. So, how does that help us find this arc WY, or this A? Well, this is an arc, right? It cuts off. So what can I find? I don't know this, do I? See this WV? Oh, we're going to have to find that anyway. Hold up. Let me see something. Did I miss something? Oh, no. Okay. Well, wait a minute. Hold on. Hold on. Oh, you know what? Yeah, we're going to have to do a little bit of stuff before we find that. Let me see. All right. This is going to be a little confusing. Everybody awake? You need to be awake for this. All right? I promise. This is not going to be super easy to see. Watch this. I can find this arc or this angle right here. How do I find that angle right there? 40 minus 28.5. And that is 11.5. All right? Everybody with me on that? So that wasn't hard. What I want to do is I want to find this arc. Let's mark it so that we can see it. Oh, oops, that's ugly. Okay, that's the arc we're trying to find. Everybody good? All right. Problem is, I know this angle, and I don't know either one of these arcs, do I? So how in the world am I going to do that? I should subtract them, right? I should subtract this WY from this WV, subtract and divide by 2, and I'd be good to go. But I can't do that because I don't know either one of those. I could kind of find WV. All right? Tell you what, let's get rid of this stuff. Just give me some room. Watch this. I could kind of find WV. Because look, if I add up all those arcs, what should they add up to be? 360. So let's do that. So let's go 360 and then subtract these things. Okay, subtract 145. What do I get for that? That's 5, that's 10, that's a 5. That's a what? 1 and a 2, 215. Is that right? All right, so 360 minus 145 is 215. Take away an 88. What's that? That's a 0, that's a 5, that's a 7, that's a 12, 127. Yeah? Okay, so if I take away 145 and I take away 88, I get a 127. But that means that this right here, this WV, I can't find exactly what it is, but if I go 127 minus A, you watching? If I go 127 minus A, then what's left over? This WV. So WV equals 127 minus A. So here's what we're going to do. We're going to take this little angle right here. Remember, the angle is equal to the two arcs, the difference of the two arcs divided by 2. Ooh, looks like a smiley face or a sad face. I don't know, one or the other. All right, you with me on this? So if I take WY minus what? WV, whoops, almost wrote a Y again. WV, I don't know why I'm writing so small, but there you go. So this angle, and we know the angle, don't we? What is the angle? 11.5. So watch again. You might be lost, but I'm going to get you back on track. This angle right here is equal to, and I'll tell you what, let's do the WV. Do it in blue since West Virginia is blue and gold. All right, so there's the blue right there. Looks like WV colors, okay? So watch. That angle is equal to what? This yellow arc minus the blue arc divided by 2. Yes? Okay, so let's write that down. Well, we kind of did. But instead of WY, what am I going to call it just to make it a little easier? What did we call it? A. We just called it A. All right? And, I still got 2 unknowns, right? So what I'm going to do, hold up, let me think about this just a second. minus.
Are we gonna have fun with
Wait a minute. Don't. No, we don't do that. Just sit and watch and listen. Okay? That doesn't help. So, 127. All right, I wrote something weird down. I don't know why I wrote it like that. Let me try to interpret what I wrote down here. Here's WY. Okay, that's a A. Oh, okay. Look, yeah, here we go. Everybody watch? I got it now. I don't know why I didn't see it. I wrote it down right here. What's WV equal to? It's 127 minus A, isn't it? So watch this. So I'm going to write it down. 11.5 equals A minus WV. What's WV? 127 minus A. Now, we're subtracting that whole thing, so I got to do that. And then, what? Divided by 2. Okay? So, just follow along. You write it down. At least you're writing it down. Okay? You can always go back and look at it and see what's going on. So now, what I want to do is I want to solve for A. Now I can solve for A. How do I do that? What math do I do? Now it's just algebra. I have to get rid of that 2. How do I get rid of the 2? Multiply it by 2. All right, so that goes away. So what is that? 11 and a half, that's 3? Yep. So 23 is equal to, now what do I do here? I'm going to go A, what? Minus 127, and then you're distributing that negative. Minus negative A, which is plus A. And now what we can do is we can solve for A. We should be able to do it pretty easy now. So 23 equals, A plus A is 2A minus 127. Again, let's get A by itself. So I'm going to add a 127 to both sides. That cancels. And that becomes, what does that become? 150 equals 2A. Divide both sides by 2. What's A? It's 75. All right? So, let's come up here. Remember that second part? I kind of erased it, but the second part was to find WY, which is A, and I just found it. What is it? It's 75 degrees. Correct? So now, how do I find WV? Remember this? WV was just 127 minus A. Well, I found A, so what is WV? It's 127 minus what? 75. And that is 52. That's 52 degrees. So that is WV, arc WV. I know I got a little messy in there, but that's how we do it. That was, I told you, it was a little bit tougher than the ones we did before. All right, so I told you to snap out of it, wake up, all right, and see. The hardest part was because you had 2 things unknown, right? You had 2 unknowns. But we wrote down, remember, this blue one is equal to 127 minus the A. I think everybody sees that, all right? Then the key to this problem was this. I know it's really messy in here. The key was take that angle, set it equal to A minus WV. Well, WV was what? It was 127 minus A. So you put the 127 minus A in for the WV. Then after that, it's actually, this was probably the easier part of this whole thing, was just doing the math. You do all the math, you get A, which is that WY, and then you plug it back in for this to get WV. 127 minus that is 52. All right, so that is how you do that. What I would do if I were you, I would write this problem down from scratch, okay? Maybe watch the video, have it playing, right? do as much as you can. If you get stuck, you watch what I explain on the video, right? Keep doing that until you don't have to watch the video anymore. If you can just write it down and do it from scratch without getting any help, then you should be good. All right? That's what you need to do. Does that take extra time and effort? Absolutely. But that's how you're going to learn how to do something like that. Could this be on a quiz or a test? Absolutely it could.
Oh.
All right? If I do it in front of you, it absolutely means you could do it. So 16 to 30. I really doubt they're going to give you maybe any of them that are quite that difficult. Okay? They might give you one or two, maybe. Okay? But that's your homework right there.
They gave us the, what do you call it? Remember the one with the crazy problem
The
one?
crazy problem one? Yeah.
Yeah, that one was insane.
All right, there you go. That's your homework. Have that finished for tomorrow. We'll go over that tomorrow.